So today we're going to do 9-4 solving linear systems by multiplying. Essentially, this is the elimination system. We just want to make sure that we still eliminate what? One variable, the x or the y. Essential question of the day. How can you solve a system of linear equations by using multiplication and elimination? It's quite simple. Multiply one or both equations. Now that's important. One or both equations so that one variable can be what? Eliminated. How do you eliminate something? Take it to zero by using addition or subtraction, and then solve the system by elimination. Vocab of the day: least common multiple, what we call the least LCM. Okay, that is nothing more than the smallest number that two numbers are factors of. Okay, that's not even a math definition of this, but it's one of those that hopefully it makes sense to you. The smallest number that two numbers are factors of. That means that they can divide into that number, okay? So if I take, for instance, 1 and 3, well, what's the smallest number that 1 and 3 can both divide into? Well, 3. Simple as that. 3 divided by 1 is what? 3. 3 divided by 3 is what? 1. So it comes out even. Therefore, they're both factors of 3. Really simple. What about 4 and 6? Well, 4 doesn't go into 6. But if I take 4 times 6 is 24. We know that both of them go into 24. But is that the smallest number that they both go into? Well, no. It would be 12. 12 divided by 4 is what? 3. 12 divided by 6 is what? 2. Both are even. Therefore, 4 and 6 are factors of 12. And it's definitely a lot smaller than 24. Okay. What about 4 and 10? Well, again, 4 doesn't go into 10. 4 and 10 do go into 40. But what about 20? 20 divided by 4 is what? 5. 20 divided by 10 is what? 2. Since they're even, they're both factors of that number. So how do we do that? Well, here's where we get this from. The factor tree. Okay, we all should be very familiar with the factor tree. What you do with two numbers, let's take the 4 and 6. Okay, you start factoring that number. Now, the way that I do it is on the left-hand side, always start with the smallest prime number. Now, 1 doesn't count, so we want to start with what? 2. What's a prime number? A number that can only be divided by 1 in itself. So 2 fits the bill. So 2 times what gets me to 4? 2. I'm done because 2 times 2 is 4. Okay. So the factors of 4 are 2 times 2. Simple as that. Now what about 6? Remember, can't start with 1, so I'm going to start with 2. It's an even number. Makes life easy. Well, the factors of 6 are 2 times what? 3. And 3 is also what kind of number? Prime. So now, let's look at these factors. I got 2 times 3. We are going to circle all the ones that are duplicates. So I have 1, 2 here. I have 1, 2 there. We only write that once. Then I have a 2 here. Any 2 over here? No. So I can write that 2. Okay. Then I have a 3 on this side. I have no 3 over here, so I write the 3. And now watch what we get. 2 times 2 is 4. 4 times 3 is what? 12. So by not writing these 2's, we don't duplicate anything that's in both, okay? So factor tree makes our life a lot easier as we go through. Let's do 2 different numbers. Let's take the 4 and 10. Let's go bigger than that. Let's say 18. Okay, so 4 and 18. Well, we've already done 4. 2 times what? 2. Cool. Let's do 18. Start with 2 because it's an even number and 2 is prime. So 2 times what? We get 9. 2 times 9 gets me to 18. Now we factored the 9. 9, 2 doesn't go into 9. So what's the next prime number? 3. 3 times what gets me to 9? 3. So what are the factors of 18? 2 times 3 times 3. All prime numbers, that's the total factorization of 18. So now I have 2 times 2. Here we go. I have a 2 over here, I have a 2 over here. So I only write that how many times? You got it. You write it once. I have a 2 here. I have no more 2's over there, so it comes down 2. I have a 3 over here. I have no 3 on the other side, so I write the 3. I have a 3 here, but no 3 over there, so I write the 3. And now, 2 times 2 is 4. 3 times 3 is 9. 4 times 9 is what? 36. So my LCM of 18 and 4 is 36. That means that 36 divided by 18 is what? Plain old 2. 36 divided by 4 is what? 9. So therefore, we know that 4 goes into 36, 18 goes into 36, 36 is our LCM. Elimination by adding and subtracting. Now we did this last section. I just want to reiterate, I want to make sure that we understand when to add and when to subtract. If we look here, I got a negative 10 and a positive 10, so I know that they are called what? Additive inverses. So what do I do with these equations? I add them. So if I add them, negative 10 plus 10 is what? 0. 2 plus a negative 6 is what? Negative 4. Y equals negative 6 plus a negative 2, same sign, so I just add them up. I get negative 8. Now we do what? Solve for y. Simplify / combine like terms, nothing to do. Remove all addition subtraction, from there your variable, nothing to do. Remove all multiplication and division, from there your variable. I can divide by a negative 4, because that says negative 4 times y. What I do to one side, I have to do to the other. That turns into 1. I get y is equal to negative 8 divided by negative 4 is a positive 2. What do I do with that information? I can substitute that back into either one of them just to solve. So let's do the bottom one. So I have 10x minus 6y equals negative 2. Substitute the y in. Instead of putting y there, we're going to put what? A 2. So 10x minus 6 parentheses 2 is equal to negative 2. And now I can do what? I can solve for x. Simplify / combine like terms? Yes, PEMDAS. I can do it. Negative 6 times 2. I get 10x minus 12 equals negative 2. Anything left to do with step 1? I'm good. Step 2, remove addition subtraction. I'm going to what? Add. Add what? 12. And if I do it to one side, I must do it to the other. So I get 10x is equal to 10. Step 3, remove addition remove multiplication division. So I'm going to what? Divide. Divide by 10. Divide by 10. X equals 1. So if y is equal to 2, when x is equal to 1. So my answer is 1, 2. And that's where both of these equations would intersect. So our example number 2, when do we subtract? Well, I have a 10, I have a 10, but they're both positive. So I'm going to eliminate the y, but in order to do it, I am going to subtract the equations because they're the exact same number. So 20 minus a negative 50. Therefore, a negative and a negative is a positive, so I get 70x. 10 minus a positive 10, so 10 minus 10 is 0, equals negative 60 minus 80, that's same signs, so it'd be negative 140. Therefore, I can now solve for x. Simplify slash combine like terms, nothing to do. Remove addition subtraction, nothing to do. Remove multiplication and division, I can divide. So if I divide by 70, I get x is equal to, because that's 1, negative and a positive is a negative. 140 divided by 70 is, look, you can take that off, 14 divided by 7, 2. So if x is equal to negative 2, what can I do? I can substitute it back in. Does it matter which equation? No. So let's do the top. 20, instead of x, I'm going to put negative 2 plus 10y equals negative 60. Now what? All I have to do is solve for y. If I solve for y, 4 steps. Simplify slash combine like terms. Yes, I have to PEMDAS for my simplification. 20 times negative 2 is negative 40. Plus 10y equals negative 60. Step 2. Remove all addition subtraction. There's a negative 40 there. So I'm going to add. All right, so I add 40, because what I do to one side I must do to the other. Cancels. I get 10y equals negative 60 plus 40. So that's just 60 minus 40 is 20, but keep the sign of the bigger number. So negative 20. Step 3, remove all multiplication division. So I'm going to what? Divide. Divide by 10, divide by 10. I get y equals negative and a positive, so negative 2. So when x is negative 2, y is also negative 2. So I get negative 2, negative 2. And that is where both of these equations, when graphed, they would intersect. Okay, so let's change one equation by multiplying using LCM. And when would I have to use this? Well, I have a 5 here, I have a negative 1 here, I have a 2, and I have a 6. None of them match. None of them are additive inverses. So what do? We are going to pick one of the equations and we are going to change it. By doing what? We're going to distribute one of the numbers, a number in so that the numbers match, or they become additive inverses, okay? So what do I mean by that? Well, 5 and 1, what's the LCM of 5 and 1? Of negative 1. It's really just 5. So I can multiply this bottom one by a 5, and I know I would cancel x's. Well, what if I want to cancel the y? I have a 6 and a 2. What is the LCM of 6 and 2? 6. So what would I multiply the bottom one by to make this a 6? 3. So let's choose one. Let's just do the easy one. Let's do x. Let's eliminate x. Okay, if I'm going to eliminate x, I need to multiply this whole bottom equation by what number? 5. Remember, laws of equality. What I do to the left side, I better do to the right side, okay? So let's rewrite this. I have 5x plus 6y equals 22. Nothing changed about that. But now I'm telling you to do negative x plus 2y is equal to, and notice I just separated so you can understand it. I need to multiply both sides by 5. That's a law of equality. What I do to one side, I can do to the other. But now I need to distribute this into this binomial and put this in with the 2. So here we go. 5 times the negative x is negative 5x. 5 times 2 is what? 10y. 5 times 2 is also 10. And now look, I can easily eliminate my x. So they are additive inverses, so what am I going to do? Yes, I am going to add these equations. So when I add them, 5 plus a negative 5, 0. 6 plus a 10 is 16y equals 22 plus 10 is 32. Look at that. That's the process of elimination. So essentially, let's talk about this. We multiplied here, And once we multiply, we got equations that we were able to add or subtract that would eliminate one of the variables. See how simple that is? So now, all I have to do is the 4 steps to solve for y. Simplify / combine like terms, nothing to do. Remove addition, subtraction, nothing to do. Remove multiplication, division. I'm going to divide. Divide by what? 16. So y is equal to what? 2. 32 divided by 16 is just 2. Now what can I do? I can substitute y back into this equation. I could even go back to the originals. It doesn't matter because they're all equal, okay? So let's just take the top one and do it. So 5x plus 6, and instead of a y, we're going to put what into it? That's right, we're going to put a 2 is equal to 22, okay? Now we're going to solve for what? X. So simplify / combine like terms, something to do? Yes, PEMDAS. We have to multiply. So 5x plus 12 equals 22. Step 2, remove what? Addition, subtraction. So we are going to subtract. Subtract 12, subtract 12. I get 5x. This cancels out. Don't forget your equal sign. 22 minus 12 is what? 10. Step 3, remove multiplication and division. What do? Divide. If I divide by 5, divide by 5. This turns to 1. X is equal to what? 2. So y is equal to 2, x is equal to 2. So 2 comma 2. There we go. Okay, example number 2 of multiplying, find the LCM of just one of the equations. Okay, so I have a 6 and a 3. LCM of 6 and 3 is going to be what? 6. That's quite simple. Here's 11 and 3. Do they have an LCM? That's real easy. No, it's 33. All right, so let's pick which one we want to sit there and eliminate. I'm going to eliminate the x, but they're not equal right now, and they're not additive inverses. The easiest one to do is try to get the additive inverse. These are both positive, so I know I'm going to multiply by a what? A negative. Okay, what number is going to get me to 6? 3 times what gets me to 6? 2. So I want to multiply this whole bottom equation by negative 2. Why am I doing that? Why? It's a very important question to ask yourself. So I can get the additive inverse. Okay? If I get the additive inverse, what am I going to do? Add the equations. All right? So that's my thought process. And that's what we're working on here. Okay? So let's rewrite the first one. Nothing happened to it. 6x plus 11y equals 14. Now, let's do some math over here. We said that we were going to take negative 2 and multiply the bottom equation. 3x plus 3y equals, that's the left side, so negative 2 times what? 12. Okay? What I do to one side, I must do to the other. Now, let's do this. I distribute this in and put this in here. What do we get? Negative 2 times 3 is negative 6x. Negative 2 times 3 is negative 6y. Negative 2 times 12 is negative 24. So what do I do with that? Put it over here. Negative 6x, negative 6y, negative 24. Now look at what we have. Additive inverses. So now I can add the equations. 6x plus a minus 6x, 0. 11 plus a negative 6 is 5. So I get 5y. 14 plus a negative 24 really says 24 minus 14 gets me 0, gets me 1. Keep the sign of the bigger number. So I get negative 10. Now, what do we solve for? Y. So when we solve, simplify / combine like terms, nothing to do. Remove addition, subtraction, nothing to do. Remove multiplication, division, I'm going to divide. So I divide by 5, divide by 5. I get y equals negative and positive is a negative 2. Make sense? Now that I know that y is equal to negative 2, what do? I can substitute back into either equation. Let's do the top one. So 6x plus 11y equals 14. I know that y is negative 2. So 6x plus 11 times, instead of a y, I put negative 2 equals 14. What are we solving for? X. When we solve for anything, what do we invoke? The 4 steps. Simplify / combine like terms. So, anything to do? Yes. PEMDAS. That's how we simplify, multiply. So here we go, 6x. A positive and a negative is a negative. 11 times 2 is what? 22 is equal to 14. Step 2, remove all what? Addition, subtraction. So I am going to add because there's a minus sign here. So plus 22 plus 22. So I get 6x, this cancels, equals 36. Third step says what? Remove multiplication and division. So I'm going to divide. Divide by what? 6. Divide by 6. This turns into x equals 6. Does that make sense? So I know that y is equal to negative 2. X is equal to 6. So my answer is 6, comma, negative 2. And this is where both of these equations, if I graph them, that's where they would intersect. Okay, so not everything's so easy as the first one, where I only have to change one equation. Sometimes I'm going to have to change 2 equations so I can get the LCM. Okay, so now here we go. Let's look. I got a 2, I got a 5, I got a 3, I got a negative 2. 2 doesn't go into 5, 5 doesn't go into 2, 3 doesn't go into 2, 2 doesn't go into 3. Which one am I going to eliminate? Since we did so many of the x's, let's find the LCM of this 2 and 3 so we can cancel out the y's. So naturally 3 is a prime number and 2 is a prime number. Therefore, the LCM is just 6. So how or what number do I multiply the top equation by to get this 3 to be a 6? You guessed it, 2. So put parentheses around the whole thing. We're going to multiply the whole thing by 2. What about the bottom one? How do I get this 2 to be a 6? You're right. Multiply it by what? 3. So now we're going to get 2 different equations, but they're exactly equal to the original ones. Okay? So here we go. Let's do all this math. 2 times 2x plus 3y is equal to 2 times negative 1. Remember, what I do to one side, I must do to the other. So here we go. I'm going to distribute this in and put this together. So 2 times 2 is what? 4x. 2 times 3 is what? 6y. 2 times negative 1, negative 2. So 4x plus 6y is equal to negative 2 is exactly the same as saying 2x plus 3y is equal to negative 1. Okay? So now let's go over here. Let's do the next one. 3 times what? 5x minus 2y equals, remember, what I do to one side, I must do to the other. So I'm going to do this right here. 3 times 5 is what? 15. So I get 15x. 3 times negative 2, negative 6y. 3 times negative 12, negative 36. Notice 6y, negative 6y. Additive inverses, correct? So here we go. Let's put them together. 4x plus 6y equals negative 2. 15x minus 6y equals negative 36. What am I going to cancel? The y's. How am I going to do it? If they're additive inverses, what do I do with these equations? You got it. We're going to add. Okay? So 4x plus 15x is what? 19x. 6y plus negative 6y is just a 0. Negative 2 plus negative 36, that's basically saying the same sign, so I get negative 38. Okay, so now with that being said, I'm solving for what? You got it, for the x. Step 1. Simplify / combine like terms. Nothing to do. Step 2. Remove addition subtraction. Nothing to do. Step 3. Remove all multiplication and division. So I'm going to divide. Divide by 19. Divide by 19. If you don't know this, come over to the side and do some work. This is called long division. So here we go. 19 goes into 38 how many times? Let's guess. Let's say 2. 2 times 9 is what? You got it. 18. Carry the 1. And 2 times 1 is 2. Plus 1 is 3. 38 minus 38. There you go. 0. So I know 19 goes into 38. How many times? Twice. So x is equal to negative and a positive, negative. I get negative 2. What can I do now? Here's the best thing about it. I can substitute that x into here, or I can even go all the way back up to the original equations. It doesn't matter because they're all equal to each other. Okay, so now let's just substitute it into the top equation. So I get 4. Instead of an x, I put what? Negative 2, because I just said x is equal to negative 2 plus 6y equals negative 2. Okay, so that's the equation right there. Now, we're solving for what? Y. Simplify / combine like terms. Anything to do? Yes. PEMDAS. Y. We're just going to multiply this. 4 times negative 2 is what? Negative 8 plus 6y equals negative 2. Step 2. Remove what? Addition, subtraction. I'm going to add, because this is a negative 8. So I add positive 8. Okay. So I got that. This cancels. 6y is equal to, what's 8 minus 2? 6. Step 3, remove multiplication and division. I'm going to divide. So I divide by 6, divide by 6. Y is equal to what? 1. So if x is negative 2, y is 1, my answer is negative 2, comma 1. And this is it where they would intersect if we were to graph them. Okay, so example number 2, when we have to change both equations through multiplication in order to find the additive inverse. Okay, so now let's look. I got a 5, I got a 3, I got a negative 2, and a 5. None of them are additive inverses, and none of them are exactly the same. So I'm going to have to change one. Pick which letter you want to eliminate. It doesn't matter which one, as long as you pick one. So let's eliminate the x. So what does that mean? I need to find the LCM of what? 5 and 3. Well, lucky for me, 5 is what? A prime number. 3 is also what? A prime number. So all I have to do is multiply them together and I get what? 15. So now, real simple. 15 divided by 5 is equal to what? 3. 15 divided by 3 is equal to what? 5. That means I need to change the top one by what? 3. Because right here, 15 divided by 5 is 3. So I'm going to multiply this whole top equation by 3. Now, 15 divided by 3 is equal to 5. I'm going to multiply this one by negative 5. Whoa, Mr. Harris, why in the world did you put a negative 5? Well, it's going to be easier for us to have an additive inverse. I know 3 times 5 is going to be a positive 15. I know that negative 5 times 3 is going to be a negative 15. That is going to be our additive inverses. So now let's work out the problem. Here we go. I got 3 times 5x minus 2y equals, what I do to one side I must do to the other. So 3 times that 11. Let's do the other one. Negative 5 times what? 3x plus 5y equals negative 5 times what? 19. So what are our new equations? We're creating two new equations, okay? So I distribute this in, and I get 3 times 5 is what? 15. So I get 15x. 3 times negative 2, negative 6y. 3 times 11, 33. This is the exact same thing as saying 5x minus 2y equals 11. Okay? So now let's come over here. Take this, distribute in, distribute in, distribute in. So negative 5 times 3 is what? Negative 15x. Negative 5 times negative 5 is negative 25y equals negative 5 times 19. If you don't know this, come to the side, do 19, put a 5, put the multiplication. It's just one number. You know this. 9 times 5, or 5 times 9 is what? 45. Carry the 4. 5 times 1 is 5, plus 4 is what? 95. So I get negative 95, because a positive and a negative, okay? Make sure you are showing your work. So now, two new equations, and I have additive inverses. So I'm going to do what? Add them. So I got 15x minus 6y equals 33. I have negative 15x minus 25y equals negative 95. Yes, the numbers are bigger, but they will make your life easier. So we said we're going to eliminate x. 15 and negative 15 are additive inverses, so I'm going to add. So here we go. 15 plus negative 15 is what? 0. Negative 6 plus a negative 25. Same sign, so I get negative 30 what? 1. Y equals 33 plus negative 95. If you don't know it, put 95 minus the 33. 5 minus 2, 5 minus 3 is what? 2. 9 minus 3 is what? 6. Keep the sign of the bigger number. So I get negative 62. Now I can do what? That's right, solve for y. Simplify / combine like terms, nothing to do. Remove addition subtraction, nothing to do. Remove all multiplication division. I'm going to divide. Divide by a negative 31. Divide by a negative 31. They go to 1. Y equals. Negative and negative is a positive. And I know 31 times 2 is equal to 62. What can I do with this? I can substitute this y back into any one of these equations. So here we go. Let's put it into this green equation right here. I have negative 15x minus 25. And instead of writing y, I know y is equal to 2. So I'm going to write a 2 is equal to negative 95. So now we're solving for what? X. Simplify / combine like terms. Anything to do? Yes. We have PEMDAS. Y, what are we going to do? Negative 15x, nothing happened there. But negative 25 times 2 is negative what? 50 equals negative 95. Step 2, remove what? Addition, subtraction. I'm going to add. So I add 50, add 50. So I get negative 15x cancels. Don't forget your equal sign. This really just says what? 95 minus 50. Because I have opposite signs, I subtract them. Bigger number on the top, smaller number on the bottom. 5 minus 0, 5. 9 minus 5 is 4. Keep the sign of the what? Bigger number. So I get negative 45. Step 3, remove all multiplication division. So I'm going to divide. Divide by what? Negative 15. Divide by what? Negative 15. This turns to 1. I get x equals, a negative and a negative is a positive. 15 times what gets me to 35? You guessed it, 3. But what if I didn't know that? Well, you come off to the side, you put 15, put 45, let's put 3. 3 times 5 is what? 15. 3 times 1 is what? 3. But if I add the 1, because we have 15, I get 45. So that's 0. Does that make sense? Cool. So when y is equal to 2, x is equal to 3, so my answer is 3, comma 2. And this is the answer when, if I graph both lines, they intersect. We have two equations here. We want to sit there and eliminate one of the variables and solve for the other one after that. Okay. This is written because the computer, this is the way you have to write it. So I'm going to rewrite this for our practice problems and putting it all together in a format that you're used to seeing. So this says 2 times 2x plus 3 over 2y equals 11. And the other one says 5 times 2 over 5x minus 2 over 5y equals negative 12. Well, before I can add, subtract, do any of that, remember, first rule of anything is to do what? Simplify it. So PEMDAS, I can distribute this number, this 5, into the parentheses. And let's see what we get. So here we go. 2 times 2 is what? 4. So I get 4x. 2 times 3 halves. Well, let's do that math. 2, let's put it over 1. Let's multiply it to 3 over 2. How do we multiply fractions? Straight across. So I get 6 divided by 2, which is equal to what? A plain 3. So I get plus 3y is equal to 11. Now imagine if we didn't simplify. We would have had fractions and everything else, but look, it already simplified itself, so there were no fractions. Now let's do this one. 5 times 2 halves. Well, let's do it. 5 over 1 times 2 over 5. Multiply how? Straight across. So I get 10 over 5, which is equal to what? 2. So this really says 2x. And then the next one is 2/5 again, so I get minus 2y is equal to negative 12. All we did was what? Simplify the problem. Okay? Now I have to do what I'm supposed to do. I have a 4, I have a 2, I have a 3, I have a negative 2. None of them match, so they're not the same number, and they're not additive inverses. So I have to manipulate either one of the equations or both. Well, if I eliminate the x, I only have to manipulate one of the equations because I know that the LCM between 4 and 2 is 4. If I do eliminate the y, then I'm going to have to manipulate both of the equations because 3 and 2, their LCM is what? 6. Okay? So 4 and 2. What's the LCM? 4. So what do I have to multiply 2 by to get a 4? Well, 2. 2 times 2 is 4. But remember, I want the additive inverse. So 2 times 2, they're both positive. If I make this a negative 2, what am I going to get? Negative 2 times 2 is negative 4. And now I have the additive inverse. So the law of math says what I do to one side, I must do to the other. So here we go. 4x plus 3y is equal to 11. Now, this says negative 2 times 2x minus 2y. What I do to one side, I must do to the other. So negative 12 there. And I get what? I get negative 2 times 2 is negative 4x. Negative 2 times negative 2 is positive 4y. Negative 2 times negative 12 is positive 24. And now I can write that up here. I have negative 4x plus 4y equals 24. Okay, so now, with that being said, I'm able to do what? eliminate my x's. 4 and negative 4 are additive inverses, so I'm going to what? Add. Great. So 4x plus a negative 4x, 0. 3 plus 4 is what? 7y. 11 plus 24 is 35. Look at that. Canceled out everything. Now I do the 4 steps to solve for y. Nothing to do for the first step. Nothing to do for the second step. Third step, I'm going to what? Divide. Divide by 7. Divide by 7. Y is equal to what? 5. Now what can I do? That's correct. Substitute it in to one of these equations. So here we go. Let's do the top one. 4x plus 3. And instead of putting y, what is y equal to? 5 equals 11. So here we go. What are we solving for now? X. Simplify / combine like terms? Yes. We have to use what? PEMDAS. I get 4x plus 3 times 5 is 15 equals 11. Step 2, remove what? Addition, subtraction. I am going to subtract. Minus the 15, minus the 15. I get what? 4x equals, what's 11 minus 15? It really says 15 minus 11 because they're opposite signs. And I get what? 4. Keep the sign of the bigger number. So negative 4. Step 3. Remove multiplication division. So I'm going to divide. Divide by 4. Divide by 4. I get x equals negative 1. So when y is 5, x is what? Negative 1. So the original equation, which is way over here, there we go. When I graph them, they would intersect at negative 1, 5.